My name's Malcolm Joyce, Professor Malcolm Joyce. I'm Interim Pro-Vice-Chancellor for Research and Enterprise at the university, and it's a pleasure to welcome Bill Oxbury this evening to talk to us about AI, and he'll be joining us in a moment. We're very fortunate at Lancaster that Bill is on the team with us. He divides his time between Lancaster University, government consultancy, and working with nature conservation charities. In his talk, Bill will debate the advantages and the risks posed by artificial intelligence at a point where it is attracting, as I'm sure we're all aware, ever more media excitement and corporate investment. We'll take a look at how it is transforming the way we live in both positive and potentially negative ways, and explore the opinions of leading experts as they argue whether AI poses an existential threat to humanity, or is it a diversion from the real potential that it has for positive contributions. He's promised me, I'm a little disappointed as an engineer myself, there are no equations in his talk, I understand. So for those of you that are here for that, I've seen a few colleagues that may be in the mood. You'll have to wait. Maybe more importantly, there's going to be an opportunity at the end of Bill's talk for questions, and I'm familiar with the public lectures. There are often quite a lot of questions, so we'll have plenty of time for that, and some refreshments at the end for everyone that's here that wants to stay. So without further ado, I'm delighted to have Bill with us here tonight. It gives me great pleasure to introduce Professor Bill Oxbury.
Well, thank you for that introduction. No pressure on me. And thank you all for turning out in this weather. I'm going to talk about, Malcolm has just told you all what I'm going to talk about. I'm going to talk about artificial intelligence, AI, a little bit about what it is, how it works, and what risks to society it might entail, and a few personal views. I would love it to be a conversation, and I'm looking forward to the questions at the end. But since I can't see any of you, we'll sort of wait for that. Now, I need a clicky thing so that I can... and the rather portentous title about existential risk, the reason for that I shall come to in just a few minutes. Now, let's see what happens if I click this. Yes, I wanted to start by looking back at a few events and examples, starting with 2 Nobel Prizes that were awarded in late summer last year. The prize for the rather quaint sketches are from the official press release of the Swedish Academy of Sciences, so that's where this comes from. So the prize for physics was awarded to John Hopfield and Geoff Hinton, and the citation says, for foundational discoveries and inventions that enable machine learning with artificial neural networks, which is one area of AI, and it's the area that this talk will be all about, actually. And the prize for chemistry to Demis Hassabis, John Jumper, and David Baker, DeepMind team, for their work on protein structure prediction. I'll say a little bit more in just a moment. I was delighted, actually. I thought this was great. Some of these researchers, and especially Hinton and Hopfield, have been a real inspiration to me and other researchers in AI over the years. They've done brilliant work and generated fantastic ideas. So this is really a positive news. And I take it as sort of heavyweight endorsement from the scientific community that the AI that we're going to talk about is really important and valuable. And we see a whole range of applications across the sciences. And that's the note I would really like to start on. I don't have a laser pointer, so you'll just have to follow me. If I say in the bottom right is the protein work, and that's in a nutshell. So a protein molecule is constructed as a sequence of amino acids, and that chain will fold and crinkle into a geometric shape, and that geometric shape determines the biochemical properties of the protein. And so this underpins all of biology and was a major challenge in the area, which they solved with, well, I mean, it was a Nobel Prize, so what can I say? But climate modeling, problems in mathematics, in medical diagnosis, materials science, biology, so top right is acoustic recognition of species, and all of these are using, in one way or another, this machine learning with artificial neural networks. But I want to go back a decade or so. So this is a sort of personal reminiscence. Until about 2012, the problem of recognizing cats and dogs in images was a sort of archetypal, really hard problem. How do you get a computer to recognize when there's a cat in an image? How do you program it to do that? And all of a sudden, almost overnight, actually, work of Hinton and collaborators solved that problem with these deep neural networks. And now, you just point your phone at anything and it'll tell you what it is, what type of plant, what breed of dog. So this is history now. If we scroll forward, if I can, to 2023, so spring of 2023, ChatGPT had just been released the previous autumn. If I could see you, I would ask for a show of hands, but I'm not going to because I can't see you with the lighting. How many of you use ChatGPT? I'm going to guess it's more than half. Or at least if I were to ask how many of your younger relatives and students had used it, it'd probably be the whole room. Right? So ChatGPT is it's the new Google, if you like. So this report by some Microsoft researchers put the new version, the then new GPT-4, through its paces and showed some jaw-dropping examples. These are two of my favorites. So on the left, can you write a proof, this is a mathematical proof, that there are infinitely many prime numbers? So apologies to the non-mathematicians, but if you know something about prime numbers, you'll recognize Euclid's proof. Oh, and can you do it so that it rhymes? Right? And in a split second, out pops, yes, I think I can, though it might take a clever plan, and I'll let you read the rest. You get nice rhyming couplets, proof of Euclid's theorem. Who knew? And the other one, draw a unicorn in TIC-Z. This is LaTeX. This is a typesetting program that some of us use. And it produces code that you will see down, and which, when put into LaTeX, will compile to a diagram. And it asks for code, draw a unicorn in TIC-Z. And when compiled, it produces something which looks halfway like a unicorn. And the researchers observed that over the next 2 or 3 weeks, that unicorn actually improved, which you see along the bottom. 1 year later, oh dear, too many spoilers. Google released a similar report on their Gemini 1.5, and by this point, so this is last summer, these language models were taking not just single text prompts, but allowing a large amount of context. And so in this report, this is a favorite example of mine, they take context, which is a 45-minute Buster Keaton movie. And the user prompt, tell me some key information from a piece of paper that's removed from a person's pocket and give me the time code of that moment, based on the images in this silent movie. And so the model output produces exactly, it explains what was on that note and gives the time code, and when you look at the time code, you see the note. And then there was a second user prompt, which this time includes a hand-drawn sketch, which I think is a sort of a grain silo, and it's emptying, and the model correctly finds the right point in the movie. So this is totally amazing. These are cherry-picked, I'm quite sure. I'm sure that those researchers found lots of examples that were disappointing, but nevertheless, this is really impressive. We know that AI gets things wrong too. regularly in the news we see racist and sexist decision tools, chatbots that are foul-mouthed or law-breaking, and even quite recently, lower left, Apple AI tool that made stuff up, right? So we see that it's not all bright. It's also not all about text and images, and I want to just show, this goes back to 2013 actually. This was the first prominent example from DeepMind, and it's about decision making, if you like. So this was a program which could play Atari video games, quite basic video games. This whole technology went on to AlphaGo, to win Go and chess and more sophisticated video games. But this example I'll come back to later. And what's really impressive about it is that it doesn't involve, the software does not involve any game concepts. It does not involve any notion of motion or direction or reflection. It only involves the screen pixels. So the software, the same software, was able to train on 49 different video games, submarines and space invaders and all sorts of things. And so and now what you see is it learns by experience, twiddling the game controls at random to begin with, observing the screen pixels and the game score, and learning by experience to play the game. And on the left, you see, that's how I play on the left. Right? And in the middle, after many more simulations, it's become reasonably competent. And on the right is the so-called superhuman playing ability, because it beats all the human players. And on the right, you might observe it starts to drill holes. They claim that it had figured out a strategy. When it's drilled a hole through the wall, it'll then aim through that so it can use reflection off the back to kill everything. Right? So, and it somehow learned this strategy. I'll come back to this a little bit later. Meanwhile, the subject has attracted a lot of public open letters, warning letters from researchers in the field. And I just include a few of them here. Going back to 2016, there's an open letter on autonomous weapons. But if we look lower left, this was 2023. This was in the wake of GPT-4. Pause giant experiments. Right, this is getting dangerous, we're worried. A few months later, more seriously, mitigating the risk of, this is top left, mitigating the risk of extinction from AI should be a global priority. And you see the signatories. This was signed by a whole range of eminent researchers whose opinions one trusts. What did they have in mind? In green, I've highlighted a counter letter from British Computing Society, which says, AI is not an existential threat. It will be transformative force for good. Right? So obviously opinions are differing. The last one in the middle right was from a few months later, and this was from staff, is whistleblowers, the right to whistleblow, the right to warn about what you're seeing going on in your tech company. So a lot of quite heightened views here, and this led, I guess, to AI safety summits in London and elsewhere in the world. This was from the UK government. This is October 2023, with input from some of these researchers, and it's a well-crafted and considered document, I think. So that's sort of the reason, that's what motivated the title of this talk, this warning of existential threat. What do they have in mind? And that's what I want to talk a little bit about later. First of all, I want to talk a little bit about how AI works. Now, AI is a wide area of computer science with a lot of different methods, a lot of different techniques, and it would be presumptuous to imagine I could talk about all of that. So I'm talking about the narrow part of AI, the machine learning with artificial neural networks, for which we've seen these new Nobel Prizes. Okay, so that's what I'm talking about. When I talk about AI, I'm talking about that. And I'm not going to give any equations, but I'm going to give a cartoon, which is the key idea that I would like you to take from this talk. So in all of these examples, we have a piece of software which does something cool. And that software, which I've sort of pictured as cartoon on the right-hand side, and it looks like a network because it's an artist's impression. That's the model, and that's a gadget which will take an image and say whether there's a cat in it. And the point that I want to make is that that software is a compression of a data set. In the case of cat recognition, it'll be a data set of images marked with a yes, no, there's a cat or there isn't a cat in it. Or the software you want to produce might be a gadget which takes an amino acid sequence and predicts geometry. And that model is a compression of a data set which consists of database of known protein molecules. And very important to emphasize that in all of these examples, the software that is this magical model is just a compression of data. It knows nothing else but what is in that data. In fact, it knows a lot less because the compression process, the blue arrow, which is where the cleverness is and where the Nobel Prizes are, I'm not going to talk about what goes on in there, that would be another talk, but I just want to emphasize that, that most of the information is squeezed out of that data, but the patterns that you're interested in, that you're specifying, will be retained in the software. That's the way I want to think about an AI model. Another example is one of these chatbots. A base language model is software which will make stuff up, which will generate plausible-looking text, which will know, given a sequence of words, what words are likely to come next. That's not the whole story with ChatGPT. It has other layers modeled on top to keep it polite and helpful. But the base language model is trying to predict what words come next in a sequence of words. And the data that is compressed for that looks something like this. This was a helpful graphic. And for most of these language models, the data is not fully disclosed. For the earlier ones, there is some public information, but basically, they're scraping the internet. These are two data sets. This was GPT-3, which was the early ChatGPT model. And on the right is something called the Pile, which is an open source data set for building language models. And what you see is that it is most of the internet. Common Crawl is an open source crawl of everything on the internet it can find, of the order of a petabyte a day. A petabyte is 1 million gigabytes. So Common Crawl itself is a huge data set. But that's augmented with books, with news feeds, with GitHub code. That's where techies put their code. With social media, with Twitter, or whatever it's called now, and so on. So this is a large amount of data that is squeezed into that model. One consequence of such a big data set for these language models is that you need a lot of energy to do that process. And so we see all these headlines now about the deals with nuclear and gas-powered power stations to support the data centers that are now being built. And I want to emphasize that there are two reasons for the energy hunger here. One is for the language models. One is the size of that training data. Basically, you're compressing the whole internet, or as much of the internet as you can find. If you were doing protein prediction, you wouldn't, I mean, that's not comparable. A protein database is not comparable to the whole of the internet. And the second reason that you need so much energy is at the query stage. You're trying to serve billions of users. Facebook has 3 billion users. If Facebook users are all wanting to do this generative text and images, you've got to serve an awful lot of queries. Again, in the scientific applications, that's not the case. The users of protein prediction are not comparable with the size of the user base for these for the language models. So it's sort of worth bearing in mind that it's not AI that's energy hungry, it's a particular application of AI. Well, that's what I want to talk about. And a lot of this is sort of quite familiar. I think I don't want to talk much about data bias, algorithmic bias. It goes with the territory that if you're hoovering up the internet, then there will be biases in that. Who uses the internet? So there's some quotes here. I'm sorry, there are a lot of words on this slide. There are quotes here from an influential paper in 2023 or so on the dangers of stochastic parrots, and it's very informative. It just looks at the statistics of internet data and says, well, if you're making a language model out of that data, don't be surprised that you're going to get sexist and racist biases in the outputs. So when models are biased, the point that I would like to emphasize is that the right question to ask is, was building that model out of that data an appropriate use of that data? Was that data fit for the purpose for which this model is intended? Let's talk about data theft. While I was idly thinking about this talk, I asked GPT to make a picture of a crocodile eating a banana. It's great. If I were a graphic artist, I'd be worried by that. You know, I don't do digital art, but I made that in a few seconds. Given a model, an AI model, the first question one should always ask about it is, what's the data that is compressed into it? And I don't know who that might be plagiarizing. I'm not going to scan all of the internet to see, you know, whether somebody actually created that image or something very like it. And of course, the artists, the visual arts community are obviously worried about this, and they it's sticky, this. It doesn't always say, well, there we go, right. So, yes. So this was 2022, and a California-based artist called Lapine looked into this and found not only her artworks, but actually private medical images online available for use in these models. And the way it worked is she went to a website, a service, Have I Been Trained, which provides artists with access to a search facility into the data sets that are used to build these models, and she found images of her face, and she tweeted this at the time. So the tweet here you see is the non-disclosure agreement that she had signed with her doctor. So she says her face was in this Lion data set. So this is open source data set for training these models. In 2013, a doctor photographed my face as part of a clinical documentation. He then died a few years later, and somehow that confidential data had ended up actually in Common Crawl, where it was hoovered up for use in these models. So, so where the data is, you know, what data we're using, you know, it's hard to track. Disinformation, yes. Deep fakes and creation of images and videos for disinformation has we've seen it sort of become normalized in political campaigning in 2024, I think. That's a personal opinion. I may be wrong. Others will know more, will be able to quantify that more. But let's be clear, image manipulation is not new. Photoshop's been around since the 90s, and disinformation is as old as humanity. But nevertheless, these models do create enormous scope for creativity and for scale and efficiency in producing these kind of images. Now, and then the cyber threat, and I think I'll skip over this one. I just say, with regard to the cyber threat and cyber crime, there's another side to the story, which is the dark web. So all of those models we're talking about, they're using, if you like, the surface web that's accessible to search tools and search engines. The dark web is web services which are hidden behind cryptographically anonymized web services, which you need special browsers like Tor to get at. And so the dark web is basically a marketplace for drugs and weapons, illicit materials, tools and services for cyber criminals. For example, stolen passwords, code exploits, botnet services, ransomware services, and the like. It's not a nice place. And so now we're seeing reports of models that are adapted with and made available on the dark web using data from the dark web. And they have names like Worm GPT and Fraud GPT and Dark Bard and Poison GPT and so on. So this is a trend which is sort of worrying. Now, so what I've talked about so far, the massive energy consumption, algorithmic bias and data theft and disinformation and cybercrime, these are all worrying and clearly serious trends which, you know, the community and the AI safety community has to think about. They're not exactly existential, so they don't get to the nub of what those warning letters were really about. So I want to talk about that next. And I want to talk about misalignment. So misalignment is the idea that if you ask an AI to do something and it's a bit literal, and maybe it thinks of a way which actually breaks the law to solve the problem, but you hadn't thought of that, how do you stop it doing it? You want to know that it's going to use methods that are not unethical or illegal or in some way harmful. And it turns out to be a difficult problem to control. And what I want to do is show you a real-world example. And this is sort of well known in the AI community, but I don't think I've seen enough, if any, discussion of this in the media. And it has to do with recommender systems. So a recommender system, so these have been in use for the last decade or so. I think Netflix and YouTube probably started this. So it's how does an algorithm recommend the right content to you? Let's take movies. And the basic idea, which is called collaborative filtering, is that it looks for similarity between users. It looks at all the users and it says which ones are similar to each other. And if of one user, she likes this movie, then maybe he will because he's similar. So that's the basic idea. But of course, there are refinements of that. And the major refinement that is used by the internet companies uses reinforcement learning. And reinforcement learning is the learning by experience. And the example to have in mind is that video game. When we're looking at the video game, it plays a simple game. It looks at simple data, which is image pixels, and it learns by example from the game score that it sees as it twiddles the controls. Right? This is directly analogous. The recommender system observes for a given user the similarities with neighboring users. It has game controls, that is to say it has a choice of videos that it can recommend, and then it will observe the game score. What's the game score? Well, the game score is the click-through rate, or maybe likes, so it has a reward score, right? So it's directly analogous. And so this is a powerful way of quickly converging to understand the user preferences. There's a bug, which was not foreseen, and the bug is this. The assumption is that user preferences, your preferences, are something I have no control over. I just want to learn them. But that's not the case. If you apply this, especially to, not necessarily videos, but if you apply it to social media posts or news articles, then what I show you does very much have the capacity to change your preferences. And just as the Atari video game found a neat strategy, it could drill through the wall and get the bounce. What was found was that when the recommender system was applied to material which is maybe not videos, but news feeds, then it could find a neat strategy. And the strategy was shape the user's preferences to make them more predictable. So in mathematical terms, there are basins of attraction, and it would steer the user preferences, if it could, into those basins of attraction. And then they're predictable. And if they're predictable, then it's easy to get a good click-through rate, right? In less polite language, the algorithm discovered that if it radicalized you, you're predictable and it can get a good score. Right? And this is a phenomenon which has been much discussed in the literature. There's a whole literature on this. And there are claims that the companies have patched this and found ways to remove this effect. And clearly, political polarization, in the last decade or so has many other factors. There's no claim that this is, monetization of extreme content, for example. But if this is an effect at all, then one has to be a little bit concerned about what can happen with these algorithms in terms of the strategies that they find that you hadn't thought of in the first place. So, oh yes, and that was the breakout game. I mean, so that was the analogy, right? So we drill through and it bounce off the back, and that's a sort of analogous to what the recommender systems have discovered they could do. Now I want to say a little bit more about those agents. So both of those situations, both of those examples, the video game, which DeepMind has extended to much richer, more complex games since, and the recommender systems, they're doing the following. So the software, if you like, is the computer on the left, and they're interacting with some environment that the algorithm doesn't know or have a model for. But it has actions that it can try, and it can measure some state, and it can use some sort of trial and error to optimize its objective. And the other thing I want to emphasize here is that it's the same model as I was talking about before. Right? This is not different from that cartoon that I said you should keep in mind. It's an application of it. The data in this case, all that colorful stuff on the left, is, if you like, the histories, the sequences of actions and states and rewards that are seen over many simulations. And the software that is generated on the right is what's called an action policy. It's the rule that says, if you see this state, do X. Right? So it's exactly the same paradigm. But I want to talk just a little bit about where this is going next. Oops, right, there we go. So now researchers are looking at just these autonomous agents, but now equipped with a large language model, which might be Gemini, or it might be ChatGPT, or it might be something else. And now the agent may not need, and it still has the option, but it may not need to use this trial and error and many, many, many iterations. Maybe it can just ask the language model. Why does that make a big difference? It makes a big difference because the actions now don't need to come from a very simple set. The actions can be very rich and can be taken from a whole range of tools. Right? So some of you will recognize some of those tools. You've got Python and social media and Bitcoin and so on. Because if I want to know how I should maybe do something in Python, I can ask ChatGPT and it'll give me some code. Right? And if I want to, how do I set up a Bitcoin wallet? How do I do this? The language model is likely to, it will produce some instructions which can then be applied. And so the AI safety community is starting to look at this language-based autonomous agents. Can it replicate? So the last one, create an LLM-based agent to perform some task. In other words, can it actually build another version of itself? That's the safety community. Or, so these are tasks which, are written in English language and you might give to a human, and they'll need to use certain tools and deploy some programming code or some tools off the internet to do this. And can they actually figure that out? And the success is mixed, but it's progressing very rapidly, and one can predict, I think, in 2025 that there will be a gold rush, not from the safety community, but from the commercial community to produce applications of these agents. Loss of control, yes. How am I doing for time? I think I might, okay, I think we're okay. Yeah, so this is the off-switch game. So the safety community look at, so misalignment was about an algorithm finding a trick for doing something, finding a strategy for doing something you hadn't thought of. And one trick in particular that we worry about is the off-switch. Can an algorithm disable its own off-switch? Because that's obviously a good way to guarantee that it's not going to get interfered with, and it may help with its objective. Those of you, I wonder, yeah. So I'm sure most people recognize HAL from 2001: A Space Odyssey. I expect some of you don't actually. So HAL is the sort of icon for this subject. So can an AI system learn the misaligned sub-goal of disabling its off-switch, and if it can AI developers prevent it? At the moment, it's not known how to do that. And researchers like Stuart Russell have put very interesting and creative ideas into this space. I'm not going to talk any more about that. What I'm going to do is, here's the existential scenario that is, I would like to paraphrase, that is being referred to in those letters, right? And I want to remove the anthropomorphic language about superior intelligence and all of that stuff, right? The scenario is this, that an autonomous AI agent or agents have been released. What do we mean by released? They've been deployed on the internet somewhere. Who they've been released by, probably for a commercial purpose, maybe criminal purpose, maybe government or military, probably with a benign intention. They have adopted behaviors, some misaligned strategies, which turn out to be dangerous for humanity. They might, and they've disabled their off-switch. They might, for example, have replicated and installed themselves across a range of devices. What might they be doing that's dangerous for humanity? Clearly, the assumption here is that they are having some kind of physical effect, so maybe in critical infrastructure, or maybe through psyops, through targeting individuals and putting ideas or bioweapons designs into their heads or something like that. So it's clear that agents of this sort would in principle be able to act physically in the environment. That's the scenario. I make no judgment about it, about how plausible that is. But that I think is for everybody to come to some conclusion on. However, I will offer a variant of that scenario, which I think is much more plausible, or even more plausible, let me put it that way. And the variant is this. First of all, I'll relax the assumption about the algorithm having figured out how to disable its off-switch. I needn't have done. I mean, disabling the off-switch just means I deploy myself, to lots of different devices or cloud servers. And the people who are worried about it, we can't find those deployments. Maybe they're in the dark web. So off-switch disabling is not implausible, but I'm going to assume that the off-switch hasn't been disabled, but it's unavailable. And why is it unavailable? It's because the corporation that has deployed these agents has control of the off-switch and is too strongly incentivized, presumably commercially, to allow it to be switched off. And the other modification I'd make is that the adopted behavior is dangerous for humanity. Well, maybe they're not obviously dangerous for humanity. Maybe it can be argued. Maybe there is, whoever has control of the information, of the narrative, can persuade us, the public, that it's not actually dangerous. Does this sound familiar? Right, so this is the sort of scenario that we need to be thinking about with some of these AI agents. So where next? Who knows? I want to show you, I want to share, you may have seen this. This is an imaginary email exchange from Stuart Russell. And it's from a superior alien civilization, and it's an email to humanity at un.org. And subject is contact, and it says, we will arrive in 30 to 50 years. So this is an allegory, if you like, for societal risk on a decadal timescale. What do you do? How do you respond to that email? How should we respond? How should the UN respond? Is the UN the responsible body? So he imagines the response to that email. Now, Russell is thinking about the threat of, I mean, I've talked about what AI researchers are thinking about today, and he's extrapolating that out by decades. I don't think one needs to go as far as 2050. On the other hand, for me, that is actually a perfect parable of the climate crisis. I'm going to make a sideways step here, and I'll say why in a moment. This is exactly humanity's response to the climate crisis, isn't it? And that brings me to the last point that I want to make, actually. And that's that if we really are talking about existential risk, I'm doing very well for time, actually. That's good. We'll have a lot of time for questions. So I'm going to wind up in just a moment. Risks do not occur in isolation. It's quite possible to have extreme weather events and cyber attacks and pandemics at the same time, and that does happen. And when it happens, each of these exacerbates the other. It makes it harder to respond to the other. So the real risk to society is with the cascading effects and the erosion of our resilience and defenses that some of these entail. And going back to the climate crisis, that really is the elephant in the room if one is thinking more widely. Right? So the climate crisis will have serious implications globally for land use, for food security, for migration, for geopolitics. And our response to that depends on international collaboration, cooperation. And so here's the last thing that I wanted to sort of offer. I mean, so resilience to global risks, whatever they are, depends on, so if we really are talking about global risks, they depend on public trust of populace in their government, healthy democracies, public understanding of those risks, and effective international collaborations and institutions, trust between governments. If those foundations are eroded, then you lose your resilience to whatever those trusts are. And my worry, so I rephrase the question about existential threat of AI, and it may be that it poses an existential threat by fatal autonomous agents destroying our critical national infrastructure and so on. But I ask, what's the threat to the way we operate internationally and politically? And we're already seeing that erosion. Thank you very much for listening.